Okay, so moving average is the topic today. So moving average in time series is basically a statistical method which is used to smoothen out the short-term fluctuations, and they highlight the long-term trends or cycles in data also. And it works by averaging a specified number of data, basically the data points from a time series, progressively moving along the series to produce a new series of averages. So moving averages can be calculated for any number of time periods. For example, a 3-month moving average is calculated, a 7-day moving average, or maybe a 4-quarter moving average also is calculated for this purpose. Okay, after this, so we are going to take an example to explain this. Here, as you can see, we have taken a table where the monthly sales review data are being allocated, which were collected for some company for an year, maybe 2022-23. So let's just see how it. So not just that the data has been tabulated, I'll show step by step how further we have to move on. So we'll create another table with 5 columns, as you can see in the slide here, and we'll list the data item given in the columns 1 and 2. The first 3 rows from the data given in the table in the last slide have been input in the table in this table. So now that we are done with step 1, in step 2 we'll calculate the 3-month moving average here. So here we'll add together the first 3 sets of data. For example, it would be January, February and March. This gives a total of say 125 plus 145 plus 186, which is equal to 456. Now we'll put this total in the middle of the data we are adding. So in this case, across from February, we'll put this data, as you can see here. And then we'll calculate the average of this total by dividing the figure, this figure by 3, as the average is usually calculated. So the figure we divide here will be the same as the number of time periods we have added in our total column. Our 3-month moving average is therefore here would be 456 divided by 3, which is equal to 152. Okay, let us move to table number 4. So the average needs to be calculated for each 3 months period, and to do this we need to move our average calculation down by 1 month. For example, the next calculation will involve February, March and April. We'll skip January. The total for these 3 months would be like here, as you can see, it's 145 plus 186 plus 131, which comes out to be 462. And the average would be 462 divided by 3, which is 154, as you can see in the table. And the same will kept on repeating for the coming next set of 3 months. So further with this, we move to the third step, which is calculating the trend. So the 3 months moving average represents a trend from 0. This suggests that the sales revenue for the company, we have taken an example here, is on average growing at a rate of $2,000 per month. As you can see, the data is given in thousands. In the example, we can see that there is a clear picture, clear trend in this, that each moving average is $2,000 higher than the preceding month moving average. Now in the fourth step, we'll calculate the seasonal variation. So once the trend, just like we saw, there was an increase of $2,000 each month. So once a trend has been established, any seasonal variation can be calculated. The seasonal variation can be assumed to be the difference between the actual sales and the trend, which is the 3 months moving average here. So it is the difference between the two values. Using the additive model, in table number 5, if we observe, we can see that every first month has a variation of -7. That suggests that this month is usually $7,000 below the average. Every second month has a variation of 32 in positive, suggesting that this month is usually $32,000 above the average. In month 3, if we see, the variation suggests that every third month, the actual will be $25,000 below the average. In the additive model, it is assumed that this pattern of seasonal adjustment will be repeated for each 3-month period going forward. Now in table 6, we have used the multiplicative model. So as you can see here, in first month, month 1, we can say it, we can call it, is usually 95% of the trend. Month 2 is 121% and month 3 is 84% if we goes in percentage terms. The multiplicative model is a better method to use when the trend is increasing or decreasing over time, as the seasonal variation is also likely to be increasing or decreasing by nature. There is little more to note that with the additive model, the 3 seasonal variations must add up to 0. There we saw that the observation was 32 minus 25 and minus 7. So we add 32 minus 25 minus 7, it comes to 0. Where this is not in the case, an adjustment model must be made, where the adjustment must be made accordingly if it doesn't result in that. With the multiplicative model, 3 seasonal variations add to 3. So if we add 0.95 plus 1.21 plus 0.84, it comes to 3. Why? Because it's 3-month average. Had it been the 4-month average, the 4 seasonal variations would add to 4. Again, if this is not the case, the adjustment shall be made accordingly. Therefore, the simple conclusion says that moving averages help in analyzing time series by reducing the volatility, making it easier to understand the underlying trend or patterns. Hope it could help. Thank you.